Today we begin the topic that explains why the Earth is dynamic, why it's constantly moving, why it's in constant state of change. And this begins for us with the whole notion of continental drift, which brings us to yet another geological hero of mine, Alfred Wegener. Alfred Wegener is responsible for that book cover that you see there, Origin of Continents and Oceans, that he wrote in the early 1900s. The basic gist of what he said was that he had evidence to show that the continents were once together, but they have separated and they have drifted or moved to their present positions. In map form, this is what he's talking about. In the bottom, you see the map of today's world with the continents and oceans that you know. But if you step back through time as you go upward in the slide, you see that as the million years and millions of years click by, the continents were together until about 200 million years ago, really a little bit older than that, 250. All the continents were together as a single continent, Pangaea. Well, you need to know some words. First of all, Pangaea is the name of the one world continent. If you have one continent, then you have one ocean, and that is Panthalassa. And the southern part is particularly important, so that one we call Gondwana land. That one was one of the areas that in particular drove Wegener to realize that his idea was true. The other terms, Laurasia, that's just for the northern half, and I'm not going to test you specifically on that. And then Tethys is a little seaway of Panthalassa. That'll become important later. So, on this slide, Pangaea, Panthalassa, Gondwana land. Well, what was Wegener's evidence? He had several groups of evidence. The first is that if you go to all of those southern continents, you see the same rock types in the same stacked order. What that means is that the same environments existed in all of those places at all the same times, and that's just too miraculous to accept. If you look at those places today, Antarctica is a frigid wasteland covered in ice. Australia, sort of a Mediterranean type climate. The Karoo Desert in Africa, dry. The Himalayan mountains, very different. It's easier, Wegener said, to imagine that all of those were together, those environments, and therefore the rocks formed successively one on top of each other and laid down that stack of rocks that you see there as those color strips. Then all the continents separated, moved to their very far disparate places, and that's why we have the same rocks of the same age in all those different places. His second bit of evidence was that if you look at the continents themselves, they fit roughly like a jigsaw puzzle. He was fitting the edges of the shorelines, but he also looked at rock types, so that if you look at certain bedrock types here in the lower slide in South America and Africa, the patterns match up. It's just like completing a jigsaw puzzle where you're matching up patterns of whatever's in the puzzle. The upper slide shows that if you assemble more continents together besides South America and Africa, but Antarctica, India, Australia, in other words, Gondwana land, that you have an overprint of these glacial rocks that are present in all of those places as well. You can look a little bit closer at this Africa-South America fit today. Today, because we have satellites that can peer through the oceans and we can see the edges of the continental shelves rather than just the shorelines, the beaches, the fit is far more precise. So the blue outline would be the fit of South America's beaches to Africa's beaches. The red outline fits this edge of the continental shelf, and the fit is far more precise. So we have verified his original idea many, many decades later. His third bit of evidence was that you find similar fossils on all of those southern continents. And these are animals and plants that could not cross ocean basins. Glossopteris is a fern that, reproduced by spores. It didn't have pollen that could be blown across ocean basins. Mesosaurus is a swimming reptile, yes, but it's a freshwater reptile. And so getting it from a freshwater lake or river in South America to a freshwater lake or river in Africa, it's hard to imagine that happening. And then finally, we have the big beefy guys here, Lystrosaurus and Cygnognathus, large beasts the size of huge pigs or small cows that had big barrel-chested bodies, arms and legs splayed to the side, not a huge range of motion in their limbs. It's pretty clear that they were just slow-moving, herding animals, large ones. Again, it's hard to imagine them crossing ocean basins. A prettier picture of essentially the same thing, a much more colorful, descriptive pattern of the same data that he saw before. Well, for many, many reasons, he was ignored. He was ignored because he was a German and published this in German. We were at war with the Germans at the time. It was World War I. He was ignored because he was a climatologist, really. He wasn't a geologist. He was kind of dabbling in a science that wasn't his. And really, the best reason he was ignored was that he had no mechanism for moving these continents. Yes, he said, for instance, that all of these continents moved around, but he envisioned them moving like giant steamships, like the Titanic. Metaphor, a comparison that he could look at during his day and make a comparison. So he was ignored, and this was decades before he was starting to get vindicated with the first recognition of what we call seafloor spreading. Now, seafloor spreading involves the whole idea that the oceans themselves are split and separating. Where do we get evidence for this? In World War II, flash forward to the 1940s, the British developed sonar. So the upper picture shows a ship sending a sonar signal down. It sends a little ping down, an impulse. It travels through the water. When it hits the bottom, it bounces back, and the travel time down and back lets the ship know how deep the water is there. Now, they developed sonar because they wanted to find German submarines. So enemy submarines, if they were down at 100 feet, the signal would reach them, bounce back, and then without even seeing the submarine, they'd know, it's down there. Let's send a depth charge bomb to get them. A happy consequence of all of this work to find submarines was that we were able to see and realize the bottom is quite complex. And the bottom has, for now, let's just talk about the main feature. In the middle of the oceans, they had these mid-ocean ridges, basically a mountain chain that runs down through the Atlantic, over to the Indian, and then over up into the Pacific. It's tens of thousands of miles of mountain chain, if you will. These mid-ocean ridges are places where there are extensive volcanoes and volcanic activity and lots of earthquakes. These are places where heat is rising from deep within the earth at these boundaries, and it is spreading the seafloor apart. And this rising heat pushing up, creating these giant mountain ranges, is what is pushing these continents apart. Not the continents themselves moving, but bigger pieces moving.